Good evening students, welcome back to the class, and in today's class we will discuss about the Gibbs energy and spontaneity. Till now we have learned that the enthalpy cannot be the only factor for the spontaneous reaction. So in order that a spontaneous reaction, enthalpy change is a must, but it is not the only factor. Okay, now here we have to introduce another factor or another function, that is a state function called the Gibbs energy. So Gibbs energy is basically a chemical energy that has the ability to do work, and the denotation is G. So as a formula you will get here that G is dependent on enthalpy, entropy and temperature by the formula G equal to H minus Ts. Now when we talk about the Gibbs energy change, that is your delta G, delta denoting the difference. Okay, so whenever we talk about delta G, I mean to say delta G2 minus G1. Okay, so initial state is final state minus initial state. Now when we talk about the difference, you have to put a delta here also, right? We have put a delta G here, so delta will be here also. Now by using the associative formula or property, you can use delta H. Again this delta will be applied here as well. Clear? So delta Ts. Now you can see I have already written. So whenever we apply the function, the difference function here, as S is constant, you can take out the difference of T here. T is not constant, T is changing. That is why we can take out the difference of T, right? One time you take S as constant and second time you take the T as constant. When S is constant, you can take out the difference of T, and when T is constant, you take out the difference of S, that is entropy. Clear? So this is the ultimate reaction that you can get here. Delta G equal to delta H minus T delta S minus S delta T. Now when we talk about an isothermal reaction, what happens? Delta T becomes 0. So anything multiplied with 0 becomes 0. So S into 0 is equal to 0. So this whole term ultimately becomes 0 and we are left with this reaction, that is delta G equal to delta H minus T delta S. So for an isothermal reaction, this is the equation. Now the unit of Gibbs energy is joule. Okay, so energy is calculated in joules. So this is the Gibbs energy, and this equation delta G equal to H minus T delta S is called the Gibbs equation. Now we will move on to another topic. Here you have to learn one thing, that whenever from the system heat is removed, it is transferred to the surrounding, because in the first day itself I have told that whenever we talk about universe, it is made up of system and surrounding. When something is changing here or when something is decreasing here, somebody has to take that, and that is what? Somebody is surrounding. Clear? And when heat is transferred here, then someone is transferring heat, and that someone is surrounding. So system is always related to surrounding. If this is positive, this will be negative. If this is negative, this will be positive. So vice versa. Now when we talk about the entropy change, delta S total is equal to delta S surrounding by T, and which is equal to minus delta H system by T. It means the total entropy change, or this T means total and total means universe. Clear? So the entropy change is actually dependent on the entropy change, the enthalpy and temperature of the surrounding, as well as the enthalpy, the heat change and the temperature. So we have yesterday we have discussed how delta S is equal to Q by T. So we have learned this one, and if you haven't seen the video, you can go and watch it. Okay, so we have discussed in detail how entropy is changing with temperature and heat. So this is basically a formula here, and for surrounding this is positive. It means what? Heat is being transferred to the surrounding. Who is transferring it? Obviously only one person is there. Okay, I'm denoting as person only so that it's become easier for you to remember. So that person is what? System. So in the universe only two things are there. first person and second person. If someone is losing something, means someone is taking that up. Okay, so it is like giving and taking between only system and surrounding in the whole universe. Okay, now you know that the entropy change is equal to the entropy change of the system and entropy change of the surrounding. And when we talk about the entropy change of the surrounding, we can write this, isn't it? Instead of surrounding, we can write this term, okay, delta H surrounding by T. Again, in the next step, you know that this is equal to minus delta H system by T. So you can put here minus delta H TS. I mean to say here that delta S universe is equal to delta S system plus delta S surrounding. Clear? Let us keep this as it is and let us change this. So instead of delta S surrounding, you can put here delta H surrounding. We are going by the formula here, okay, we are not putting anything new. Again, you can write here. So now you know that whenever surrounding is there, if it is positive, then for the system it will become negative. So you can put here T and here it will be system. Clear? Now if you solve this equation, what you will get here? If you take the LCM, below it will be T and this T will be multiplied here, right? And the next step will be T will go that side. Okay, so I'm writing it directly here. Okay, so this thing you will get. We have taken the LCM and then we are solving it by basic mathematical rules. Now you know that for spontaneous process, delta S is greater than 0. For a spontaneous process, the delta S is greater than 0. Now when if this is greater than 0, if this is greater than 0 means this is positive. Clear? If this is positive and this is equal to what? This whole term, right? This total term is equal to this. Clear? So this will be also greater than 0. Means what? If suppose x is equal to a minus b. Clear? If x is greater than 0, then a minus b should also be greater than 0. Then only it can be equal, right? So that is the concept here. So now what we will do, we will bring the minus outside here. Then we can write this in front so that when we go back, we get this minus delta H system. So delta H will be here. But this is positive now, so we have to put a minus here, so that minus becomes positive here. So we are not changing anything, we are just rearranging the signs here. Okay, so delta S system minus T delta S surrounding, and we have got something here, delta G equal to delta H minus T delta S, right? Sorry, this one. So delta G equal to H minus T delta S. So we have got H minus T delta S, which is equal to the Gibbs energy. Now in place of this, in place of delta H system minus T delta system, we can put delta G system greater than 0. Okay, so there is a minus here, don't forget. So if minus delta G greater than 0, then delta G should be less than 0. Okay, let us take this. If something, if a value here, I will not write the value so that it is easy for you to understand. If a if a negative quantity is 0 here, if a negative quantity is 0 here, then greater than 0, if a negative quantity is greater than 0, is it possible? No, na? So whatever quantity is here, that has also be negative, then only negative, negative, positive. Clear? Understood? No? So I can write that this only this term you said minus a is less than 0, obviously. Understood? So here we are saying that minus delta g is greater than 0. Is it possible? If we see like this, is it possible that minus delta g is greater than 0? Never. No, because this is a negative sign and this is 0. How can this be greater than 0? Only under one condition, that delta g is negative. Delta g negative means it is less than 0. Is it clear now? So for Gibbs energy, for spontaneous process, delta G is always less than 0. Clear? But for entropy, you know, it's always greater than 0. So these two things you remember. The question can be how the Gibbs energy changes for spontaneous process. So your answer should be delta G less than 0 is the condition. The next question can be what is the condition for entropy under which a spontaneous process can occur. So your answer should be the condition for which a spontaneous reaction can occur for entropy is greater than 0. Is it clear? So this much for today, and we are done with the chapter here.